Okay, here's a little program that's going to use two machine language subroutines that are built into the ROM. So we're starting our program at 6000 hex. The first call is to jump to subroutine A1B1, which in the basic ROM brings up a cursor and accepts one key character and puts it in the A register. So we're going to compare what's in the A register to number 13, which is the enter key. Branch if equal. If we get the enter key, we're going to jump to the quit. If we don't have the enter key, here's a no operation. This is for future reference. You can put in your code what to deal with this. Now we're going to load into A an asterisk. And here's our second subroutine call. Jump to subroutine A2. And what happens there is it takes whatever's in the A register and it puts it on the current screen location. Here's an extended loop, so just jump right back there. So it's going to get a key, check it for quitting. If not, print an asterisk every time. And we're going to assemble this. Now these comments here, they're just there for us. If you were to hand code this, this would be your code here. Now you could look this up in books. JSR is always going to be BD, followed by the memory address of where you want to go to. Now A1B1 is in the color basic ROM. 3.9, you're going to recognize this as a return from subroutine. So if we call this from basic, it's going to run it. When it hits the 3.9, it's going to jump back to basic. 7E, this is a jump to this address in hex. So because we told our assembler that we want to start at 6000, that's where it's putting it. Well, you could poke each one of these into basic yourself, or you could do a little program to read the data and then just poke it into the memory address and the data. I put this extra coding in here because I like to use hex. So here's the data for the program. It's very small. You can see BD is the jump to subroutine at this location. So let's run it and see what we get. So now we're into the machine language routine. So it should, no matter what key we hit, put an asterisk, enter, it jumps out of the subroutine. So if you were to use this in your program, anytime you'd want to call it, you would just do because it's already loaded up into the RAM. So like that, we're already asking for a key. Put our keys in, done. So let's look again at the basic. Now, load A, if we look over here, we have an instruction, load A number 42, which is 862A in hex. So let's edit our data. Edit 70. 862A. So here we're loading A, 86, with data 26. So let's change this to a couple of 12s. Now we know from here, no operation is a 12. And it's kind of handy sometimes in assembler. So let's see what happens when we run this program. Now we're going to type. Wow, look at that. Now it's showing every key that I typed. So we went and got the key from this routine. It stored it in A. Here we compared it to 13, the enter key. It wasn't, so we didn't jump. And we did a no operation. Now instead of loading A into 42, we changed these two values to no operations. So it keeps whatever value it had, and it's outputting it right to the screen. That might be useful for you, or you might want to use a password program and hide the code in machine language where people won't see it. So I hope this little example is helpful. I can give you a quick look at where I found these subroutines. This is from the Color Basic Unraveled book, and we can see console out is the A2A2. So they're showing us here that this is where it gets the data from the A register and outputs it either to the screen or to the cassette or wherever it's supposed to go.